Yeah? All right. Welcome to the ysco launch party. ysco is a brand new tool. It's being released today, so you're the first to hear about it. Yeah, it's a celebration, so feel free to pass around some balloons. Oh. Yeah. So let's do every slide that changes. You can move around the balloons a bit, all right? So this is about managed automated updates of Go services and subtitled the hard way. So this is not a tool that's hard to use. It's very easy to use, but building it was hard. So that is in part what this talk will be about. All right, managed automated updates. It may seem like this is marketing speak for automatic updates. Now, who likes automatic updates? Yeah. Who fears automatic updates? I also fear, yeah. It's a whole love-hate thing. So luckily with ysco, you stay in control. You can decide when you want to update and what you want to update. So you don't have to be fearful. It works for any Go application, but some caveats, some requirements that you run as a Go service. So it's not for CLI tools that you just run one off. It's just something that has to keep running continuously. Source code has to be available through the Go module proxy. So essentially it has to be open source. There's an asterisk here, and that's because you can in fact run it on private code, but you'll have to run a whole bunch of infrastructure. That's not too easy, so it's out of scope for today's talk. But there's integration tests in the code base, and they do set all of these infrastructure up. So if you want to run it, you can. The code has to be able to build with cgo enabled is 0, so no C libraries and so on. No, we know C is unsafe, it's bad, don't do it. I'm sure all of you are only writing pure Go code. The program has to be self-contained, so no additional files may be required, and the application should just include them in the binary with the embed package, for example. And I think it's a very common thing nowadays. So hopefully you'll have checkmarked all these things and you think, yes, my application can do this. The good thing is that no modifications are needed to your application. So you can just run ysco with it without any work on your part. Now, before we dive into the details and show a demo, I want to take a step back and discuss what a new version is of an application. So obviously, if you release, as an author, I release a new application, I give it a new version. That's a clear thing. In Go, applications are Go modules. The source is in a Go module, that's the thing being versioned. And in practice, most of us will just create a new Git tag, right? Just Git tag, push it to GitHub or whatever. And the Go ecosystem will pick up that new version. But there's a second reason to want to update the application that you're running. And that is if the Go toolchain is updated. Because if you compile your code, you get a binary, and the compiler output is in there, and the runtime of Go is in there, and the standard library, like the HTTP library, is in there. So if there's a new Go toolchain release, there's often some stability fixes, some security fixes. You want those in your running application. But if you install an application, you get a certain version, you download the binary. The application authors often don't publish new binaries or Docker images or whatnot when there's a new Go toolchain. So what do you do? And of course, if you run like CI/CD systems that for actively managed services, you probably get those updates soon enough. But that it's not happened for all the code that at least I'm running. So now we'll do an example and a little demo. I've got this very simple basic demo tool called Mox Tools, just as a thing to run. That's the thing we're going to automatically update. Normally I would start it like this, just the binary. And of course I would start it in a systemd unit file or initd script, or maybe you could run it in a Docker image. To use ysco, you just put ysco run in front of it. And then I'll explain later how that all works, but it essentially just starts this Mox Tools program and keeps updating it if needed. More elaborate example, some CLI flags. You can set an update schedule. So you can say, I only want to update during working hours. So if anything breaks, of course it never will, but if anything breaks, Now you won't be woken up at night. You can add an optional admin interface, so you can see what's going on and manipulate ysco and the updates. You can set a metrics interface for Prometheus metrics, so you can keep track of updates if they're going according to plan, when they're scheduled, etc. And then here's this monitor delay of 10 seconds that I've added for demonstration purposes. So I'm going to start this demonstration now. It's very dangerous, live demos. Okay, it's started. Opening up the ysco admin web interface. It's very basic. Managed automated updates. There are no scheduled updates at the moment. Currently running this MoxTools module version 004. And this is the latest toolchain that was released yesterday evening that you probably noticed. And we are also aware of ysco's version itself. It's just brand new, 001. That's the latest version. No old binaries to clean up, and this is how we were started. Now this here is the MoxTools applications. Mox is this mail server that I wrote and I talked about a year ago. This is just a simple demo tool that shows some of its library code. It's not really important. What's important is that we can see here what version it is running. So it's currently running version 004. And that is indeed also what we see here. Now, in the meantime, this 10-second delay has triggered a check, and it found a new version, and it scheduled an update. So we will update, when's this? Next week? It's late, but okay. It is during working hours. At 9 o'clock it can start, but we'll just update now. So it will now fetch a new binary. Oh, already done. So 005 is now running. Yeah, there we go. So that was the all in control, one click at your convenient time. We'll do update to previous Go toolchain. Yeah, replaced, and that's it. Yeah, this restarts the process. Yeah, and this is updating ysco itself. And now we can see we are running ysco with the previous Go. Built with the previous Go toolchain. And this one doesn't restart, it executes itself, so no downtime. All right, that's it for the demo, it worked. So obviously ysco is, even though it's at 001, it's very solid. Let's continue. You may still be afraid of automated updates, so let me put your mind at ease, or ysco will put your mind at ease. You can configure policies, what to update. So by default, it automatically updates only patch level versions, not minor or major. You can also just configure it to only update manually. Then you'll never get completely automated updates, but you do get notifications. But when you can update, same for the toolchain, only patch releases. But once there's a new application version, it will update. It will use the latest Go toolchain because it's assumed that if someone releases some new application, they tested it with the latest Go toolchain. And it also follows only stable Go toolchain. So if you haven't updated for a year and the current Go toolchain you were using is no longer supported at all by the Go team, it will also skip a minor version because it's probably better to do that than just keep on the really old versions. You can configure the schedule, the time at which you update, only work hours or weekends maybe. Automatic rollback, so when a new binary that's being started quits immediately, something is wrong, and it will roll back to the previous version. That's this web interface that we saw. Well, we've also already seen how it works. There's also webhooks, so you can trigger after a release to get the update found more quickly. ysco can update itself without restarting. And its name, ysco, should remind you of ice cream. So whenever you get anxious, you think, sweet, delicious, cool thoughts, and you just go for it. So how does it work? On startup, it will look at this binary that it needs to start, and will find the module path that's in there, and the version of the module, and the version of the Go toolchain that's used. And how it does that is problem one, and we'll see in a moment how that works. Then it starts the application, and this is pseudocode, but it's not far off. It's very simple. Import the OS exec package, create a new command, start it and wait for it to finish. Then, second step, in the background, periodically check for new module versions and new toolchain versions. That's problem 2 that we'll look at. And let's see. When it's ready to install an update, it will download a new binary, problem 3, that we'll look at. It will shut down the application by sending a terminate signal. It will replace the binary, or just a symlink actually, and start the application again. So, problem 1 was figuring out what the binary is, what kind of Go module it is, and which version it is. All this information is luckily available in all binaries compiled with the Go toolchain. If you run go version -m on the binary, you get all these details, like the Go toolchain, the Go module, and its version. You also get all these hashes, but ysco doesn't need them. There's also a package path. In this case, it's the same, but it could also have this command / something behind it, because Go modules can have multiple packages inside. Then there's all these dependencies that we don't need, but it's there. And we see these build properties, Go enabled to 0, Linux AMD 64. So the information is in each binary, and there's also a parser in the standard library. So problem 1 was very easily solved. Problem 2, now it gets a bit harder. Checking for Go module updates. How do you find, for a given module, if there's an update, which versions are available? Does anyone know? The proxy, yes, the Go module proxy. So there's this thing run by the Go team, and they essentially keep all the Go modules and versions on their proxy, and all the Go tools go through the proxy to request these modules. That's why you can get them very quickly. And the Go module proxy periodically goes to the GitHub and whatnot to fetch the latest versions. So there are a bunch of endpoints. You can get the special @v/list. And you get all the versions that are available. So all the Git tags basically on this application, on this module, on this Git repository. It's just a text file, new line separated, just simplified versions. There's this endpoint for the latest version. It's JSON, shown here in parsed form, but this is just JSON. 005 is the latest time it was discovered that it was coming from Git. Then there's again a JSON for an explicit version. It's the same JSON because it's the latest version. And there's the Go mod that you can request of a specific version. Well, you can use to find all the dependencies required. And there's a zip that contains all the Go files that you need to compile the module. So, there's also this cached only endpoint that won't. So sometimes for these things here at the top, sometimes the Go proxy will go to GitHub and make you wait until you get a response. With the cached only endpoint, it's always fast and it only uses its cache. Now checking for the new Go toolchain. Any ideas? Well, there are many options. First of all is to the Go module proxy, because this special module, golang.org/toolchain, lists all the versions. So these again are like complete version. This is the 001 is a fake version. You can ignore it. This is essentially a pre-release tag that sometimes comes after a real version. For each Go version ever and each supported platform, there's a line in here. So this file is pretty long. This is about 100 kilobytes. Contains all the available Go toolchains. Oh, wait, let me shut down this thing here. You can go through the Go website. There's this go.dev/dl page, which normally serves HTML, but you can get JSON out of it. And it will say, latest version, this is a stable one. There's a whole bunch of files, source, hashes to check, and for all the platforms you can get the files that you would need to download. There's also an endpoint to include all the historic ones, and you get a 1 megabyte JSON. It's a bit much, but you can get it all. Let me see. Yeah, all right. Then how to install one of these, how to use it. Again, through the Go module proxy, because it's just a module. It's a zip that you can download, extract, and run the Go binary inside. You can verify all of this with the Go sum database, more on that later. Or you can download it through the website and verify the PGP signature. And I've got a Go module to do this programmatically. And you can also, if you already have a Go toolchain installed, you can install this sort of shim binary and download the actual toolchain. And then you can use this thing to build as normal. So that's very convenient if you are developing and you need multiple versions of the Go toolchain around. Now, the hard way. Yeah, this was too easy, right? And also there's this little downside that there's can be quite a bit of overhead. If you download 100K of data every time you want to check if there's a new toolchain, it's a bit much. So can we do better? Yes, we can. We can look up over DNS. So there's this service, goverwatch.org, and this L is a zone delegated to Goverwatch. There's an API thing, and there's a toolchain endpoint, and it will, if you look it up, I did this before yesterday. There's a version, the current version, and this is an hexadecimal timestamp, Unix epoch timestamp, when it was first discovered. And then there's also the previous version. If there's a release candidate for the future, then it will be a next entry as well. And you can do this for any Go module. We've got the same start. Then we've got the github.com host. This is a slash separator because paths and hosts are not the same, but this separates them. And we've got mjl dash. This is obviously the start of an escape of an hexadecimal dash or an ASCII dash in hexadecimal, and then the smocks tools. And then we get the latest version. So this will work for any Go module, and it's very lightweight. And it's also, so this is easy to use. The hard way was implementing it. This is a DNS server I added to goverwatch.org. So goverwatch.org is a service I built that tracks the Go sum database and will send originally emails, because I made it to test mocks, my mail server. It can also send webhooks. Now it has a DNS server, and it also does DNSSEC. That's fun. Then a side step for the Go sum database. That's a transparency log. Who knows what transparency logs are? Yes, some people, yeah. It's an append-only log that the Go team, in this case, for the Go sum database, manages with all the Go modules and versions ever encountered. And it stores hashes of the contents. And that's a useful property. If you want to look up the module you haven't seen before, you can check in the centralized database what the Go source files should be. You can verify all the contents. And you can do that with proper cryptography. That's a whole topic on its own that we can't cover today. But it's for you to get confidence that what you're getting is what everyone else is getting, and it's the same you're getting tomorrow and yesterday. And actually what it stores is these lines, your go.sum files. I assume many of you have seen go.sum files. So this is the hash of all the data, all the source code in a module. So you can look up an individual version. You get an entry like this. These are the lines that make it to your go.sum file. You should commit these to your repository because then they get distributed to all the users, and every Go application on every individual computer can just check it decentralized. But if you haven't seen the module before, this is where you will get it. It says here it's a record 30 million something. That's how many records were already added. This was the 30 million somethingth. And this is a signature on the whole thing. 30 million entries in total. This is the current state of the tree, as they say. It's one of those Merkle trees where it all hashes to one unique hash at the top. I think this is the hash that proves that makes it to the top. And this is a signature by the sum.golang.org private key. So you can verify that the tree is consistent, and the transparency log allows you to check if a later tree state is indeed append only and nothing was changed in the past. There's a really nice blog post by Russ Cox that explains how all of this works. So it's very interesting stuff. Then on to the last problem, problem 3. downloading a new binary. How do you get a new binary for this module path, for this version, Go toolchain, platform, or any other version? You can download toolchains on your servers and compile them locally, but then you have to manage your toolchains, the build caches, module caches. It's a bit of a hassle. You need lots of memory, maybe, CPU, disk. Can we use a service? That's the hard way, of course. And yes, we can. There's this service called beta.gobuilds.org, and you can use it a bit like the Go module proxy. Put in your module name and a version, your platform, Go toolchain, and this link will straight up give you a binary for this specific version. Now, there is this nice page that shows you what you get. This is the hash of the resulting binary for your verification. You can download the thing, and you can reproduce the entire build byte for byte. You can specify or select different module versions and get them built for different targets, different Go toolchains. You can get a smaller stripped variant. And it will do all this on demand. You can say, give me one here, and then it will first build it. And there you go. Made one. All right, so that's available. But now you think, wait, this random website, I'm not going to download binaries from that and run it. How is this safe? Well, as I mentioned, the builds are reproducible, so you can do the same, make the same binary, you get the same bytes, and you can verify that it's the same. And you can build them, or actually, this service builds them twice. Once it's on one machine, then on another machine, and compares that they're the same. The machines have different architectures, so as a way to put in some difference and see that the builds are the same. Then the hashes of these binaries are included in its own transparency log, just like the GoSum database. So you can verify that what you're getting is what everyone else is getting. And best of all, you can relatively easily run your own Go build instance. And then ideally, you would run your own one and make it verify against this public one. So then you can check if the public one is honest, but you've also built your own binaries. It has lookup endpoints, just like the sum database. And it has a similar structure, a record ID. There are much less. The contents of what's stored in each entry is different. And there's also the signature with its own private key. So that's pretty much the essence of how ysco works to get its binaries and why it's not completely ridiculous to do it this way. There are still some challenges, caveats. It's young. The approach isn't perfect. If you download for an application, download a binary for some new toolchain, you haven't necessarily run a test suite with that toolchain. So is that a smart thing to do? I'm okay doing it for most of my software because the Go toolchain patch releases are very solid in my experience. I've never seen any breakage, so I would be happy to do that. For most applications, maybe there's some cases where you don't want to do that, but it's your choice. Another thing is gobuilds.org is in beta. I made it, by the way. I didn't mention that maybe. And I think I want to get it into a production thing, but it should be run by a team. So I want to find other people. I want to help run it. But there's still some work to do. I want to make the builds more isolated, etc. Then the GoForward's DNS, it currently only returns the latest, one latest version. So if you have multiple actively maintained minor versions, then you'll only get the really latest version. So if you're on the older minor version, you don't get updates. You can just switch to using the Go module proxy for updates. That's an option. So if you know your application is doing that, you have the choice. Then semantic versioning for applications. So semantic versioning with its major minor patch versions is mostly defined, I think, for libraries. But what does it mean for applications? Is it safe to update a minor version and expect no operator intervention needed? Or I don't know. If anyone knows if there is a convention or what the convention is, I want to hear about it. And then authors of software applications in Go don't normally, I think, specify whether the applications use ysco. Well, you can just try to compile and see if it works. But also if they're self-contained without needing external files. It would be nice if people would specify that in their projects. All right, last slide, the summary already. So ysco manages these automated updates, not necessarily automatic. You can also do one click and be in control for any non-ysco self-contained Go application that you run as a service, and these applications do not need any modifications. So keep it fresh and run ysco. And thank you for your attention. Wow. Questions?
Where's the ysco limitation?
Mostly cross-compiling, because if you want to cross-compile, it gets tricky with the tool chains you need. So
you really want to provide your own binary provider?
Well, I don't. So this Go build service runs code or runs the tool chain, and if you say, "Oh, I've got my C compiler, can you run it for me?" Like not on my machine. I'm okay with running the Go tool chain because I trust it's good. But if you would say, yeah, I've got my binary, my C compiler here, can you run it? Then, if it's one of the standard ones, maybe I could do it. But then you'll have quickly run into the problem of the reproducibility, because they are not as easily made reproducible. And the whole point of this Go build service is to be able to prove that this is exactly what everyone else would be getting if they would compile the same code. So I think that's why the ysco, like if you wanted ysco, it will be a lot more work. That will be the really hard way. If you want to, if you want to do a future talk on that.
So ysco is more the ecosystem of everything hatched and designed than really the tool itself. The tool itself just makes you able to interface with other things.
Yeah, yes, yeah. This is so some of the software I developed. I initially started out with C dependencies, SQLite, for example, but then I figured I couldn't use all these nice things of the Go ecosystem, so I tried really hard to get rid of the C dependency. That's why I wrote this OLTB base replacement. So I wouldn't need C, and I think, for example, this SQLite is one of these dependencies that quite a few people may still use if they use C. So it would be nice to kind of get a feeling for how pure Go various applications are. In my mind, in my perfect world, almost all the Go developers try real hard to make it pure Go. But
don't you afraid about updates of the Golang version? I mean, the situation when you, for example, update your iPhone and it stopped working as it was before. I very much know that it's almost in all the cases compatible, but still there are some changes.
Yeah, no, that's it can be sort of tricky. So one thing that ysco does when it schedules a new update, like when it sees a new Go toolchain, it will at least wait 1 day before actually installing something. It could maybe wait 5 days or something, and then assuming someone's maintaining this application, they would have automated builds for a new Go toolchain. They will discover that something breaks. And they will maybe release a new Go application, like their application version, so they can prevent this Go toolchain release to mess up the running system. That doesn't not yet work with ysco. It's one of those things that I think about in the future. But yeah, there's definitely a risk that that an automatic update breaks stuff. So if you there's on the other hand, there's also a risk that if you don't update, I have various small tools. I've got a blog binary written in Go. I never update it. I think it would be better if I would just update it automatically. If it breaks, there's not really a problem. No one reads my blog, so and it generates static files anyway. So there's various situations where it might be okay. And if you really don't want to, you can just not enable the automatic installation of the updates. So I think, depending on your appetite for risk, you can configure the tool like how you want it to be. There's a question in the back.
Do you take any measurements to like minimize
No. So you can only say when you want to restart, maybe working hours, but then it will just pick pretty much any moment. So do you have anything in mind when you wouldn't want to be restarted? Yeah. No, I would be interested in checking, for example, if the application is very busy, maybe high CPU use or something. I don't even know if that's possible. I would expect it to be possible, but then you would also have to sort of keep a profile or just looking at the application is idle now and it's not in so many hours. That could be a thing, but it's very advanced. This is version 0.0.1, so. But there's also could be an interaction with, for example, backups. You don't want to. It's doing a backup. That's not a moment where you want to shut down and do an update. That can, so far you would have to look at only at your update schedule and then update. Okay. Ja.
Jullie moeten zo gaan afronden, want jullie hebben de zaal tot 8 en de volgende film gaat zo meteen.
Oh, ja, oké. Ja, nee, dank. One last question, maybe? Small question? Or do you want to wrap it up?
Yeah, one small question. Yeah, well, talking about like the rolling updates, maybe you can have like a proxy that if you can configure that if your application serves like HTTP, for example, then your update tool can spin the proxy to proxy all the requests, and if there is an update on the proxy side, you can actually pause the requests. You can drain, maybe if you know that there are sessions, you can drain the sessions, and then you can switch, run the second version.
Yeah, it would probably require more interaction, so that's a challenge. I've thought about one other related thing to both of these, and that is sending a signal so the application just restarts itself without downtime. That's sometimes possible. So the application could re-exec itself with a new binary, and if it would keep state properly with all the running sessions.
I used to do this proxy thing for Java because it has instrumentation. You can run Java agent and figure out automatically server integrations and whatnot. I guess in Go it's a little bit complicated.
Yeah, you would probably need modification to the application, which is something ysco really avoids now.
Sorry.
Yeah, handing it over to you. Yeah.